2 to 3 minutes in class. Talk to your groups about what you learned from that video. Okay? Doesn't have to be fancy, doesn't have to be specific. Talk about even what you saw, what you noticed. Even if you have any questions. 2 minutes, 3 minutes, talk about it in your last 30 seconds.
Oh, yeah.
All right, freeze. Can I have a representative from each team to stand up? I want you to tell me something you and your group talked about. We want to put that under the things we already know and see if we can go from there. Sean wants to go first. Go ahead, Sean.
The average is, like, heart thing is between 75 positive and 60 positive.
Can you be more specific about the average heart thing?
EKG.
What does a heart do?
Beat.
So what can we say about the average heart thing?
Heart rate.
Okay. Average heart rate. Okay. Anything else we think we remember, we know from that video that we watched? Okay, I think this is a pretty good start. I just kind of want to tweak some of these things. Okay? The average heart rate, yes, I believe they did say, is between 60 and 75 beats per minute. But we're really not going to be concerning ourselves too much with this information. We're not focusing on the heart rate today. Okay? We are correct in saying that a null spike leads me to doing something perpendicularly. Okay? There is another word for this. We'll leave that blank because I'm sure you guys can figure that out in your investigation today. So if I kind of like fill that in degrees, what do you kind of think we're leading towards if we're going to be talking about degrees? Yes?
Maybe angle measurements?
Angle measurements. More specifically, using an EKG. Today we will be figuring out the angle of the human heart. As this brand new doctor, you're an intern, okay? I am going to be your resident advisor for this activity, okay? And as an intern, you have 2 patients that you need to order an EKG for, all right? Those EKGs, as you can see, are right in front of you. These are real patients, real EKGs, which I think is pretty cool. So, you have to do 3 tasks with both of these patients. You have to determine where the patient's heart is located. Okay? I know you think you're going, oh, Miss Clay, it's right here, duh. No. There's a very specific place or location where this heart is, and you're going to be able to figure it out. Okay? In addition to that, you're going to figure out which angle the heart's electrical activity is flowing. Okay? And then, as we already figured out from what we already know, that angle can really tell me what's happening with the heart. Okay? And lastly, based off of that angle, you can figure out a diagnosis from there. All right? So now that we have a little bit more of a direction, I want to give you another minute. Talk about questions that you may have about this project, our next steps, and all that stuff. New representative from each group, somebody who I haven't talked to yet today. What is a question they'd like to start out with? Go ahead, Alex.
Do they actually find the angle in hospitals to see if heart surgery happens?
So can I say, is this something they actually do in hospitals? Okay? Hunter?
Well, it's like everyone's heart like in a different place. Like it's in the same place, but like a little bit different.
Is everyone's heart a little bit different?
Yeah.
How do you find, like, what angle is that, or where exactly?
How do you find the location? Alyssa?
That's what we said, how to find the location.
So I got a double on that one.
Do
Dawson?
doctors like know exactly where to go right off the bat, or do they have to actually use this technique? So.
Do they actually, so is this an actual technique?
Guess not.
Doubling up on here? Anybody have a question maybe that it wasn't talked about? Anything you want to add? So everybody knows what an EKG is, period. Then should that be a question that maybe we put up there?
Why would somebody need an
Why would you need an EKG? Why need one? Is everybody okay with me adding the question, just what's an EKG in general? You were going to say that, Sean? Speak now or forever hold your peace. Yes.
Based on like the angle at what it's at, how can you find a diagnosis?
Okay, so how can you diagnose based off an angle? Going once, twice, yes.
How would you read?
How do we read an EKG? How do we read it? Remember, these are the only ones I'm allowed to answer going thus forward. The rest is on your own. Once, twice. Sold, all right. Let's see how many of these I can help you out with. Okay? The first one, this is one 2 groups kind of were concerned about. Is this an actual technique? It is. We are interpreting real EKGs. This is what a doctor would do. Okay? Now, am I going to stand up here and say that a doctor doesn't have a machine to do this? Probably. I would bet that there's some sort of computer program that interprets an EKG. In fact, I'm almost positive. Because some of the EKGs that I had at the top had like a summarization of what was happening. It would say like abnormal rhythm, arrhythmia, blah, 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 blah. So yeah, is this an actual technique? Yes. Do they also use computers? I bet you they do. Okay? Is that a fair enough answer for this question? Does anybody need me to elaborate? Okay. What is an EKG? Anybody have an idea? Do you think that this is something I could just do a quick Google to figure out? Yeah. Somebody do a quick Google and tell me what an EKG is. Google can probably give a better definition than I can. Sarah.
It's an electrocardiogram. It's a test that checks for problems with the electrical activity in your heart.
Okay. It's an electrocardiogram. Forgive my spelling. Okay? How do you find the location? That was a double question. I don't want to give too much away because part of your investigation is going to be figuring out how to find the location. Here is the hint I'm going to give you. It's a point of concurrency. So what are my 4 possibilities if it could be a point of concurrency? Go ahead, Pat.
Circumcenter, in-center, orthocenter, and centroid.
It's going to be one of those. Okay? So if it's going to be a point of concurrency, that means somewhere on an EKG, there's going to be a what? A triangle. Okay? And where that triangle comes from is a guy named Einthoven. Okay? It's called Einthoven's triangle. And one. Yes?
I know the answer.
Well, tell me, please.
Well, an EKG is considered like one of the standard tests. So when you if you have, or if they're going to run the standard test on you, it would be like a blood test and et cetera, an EKG. So that way, if you are considered then a cardiac hazard, if you go into cardiac arrest or your heart stops, then there's a specific location in which they'll need to actually put a defibrillator on your chest to get your heart started.
I don't know if I could have explained it any better myself. We already know some of the language. We know this is positive and it's going to lead me to think something's parallel. We know what negative means. We don't really know what that leads me to do. We know this null spike leads me to doing something perpendicular. So that really was already answered from what we knew from the video over the weekend. The last step, I want to talk about this presentation component. That is going to be up to you and your group on how you want to present your diagnosis, your angle, and your location to me as your resident advisor. Okay, that's going to be up to you. You guys give me an idea of what's one way you think you might want to present. Give me an idea. I'm pretty flexible. Is it something we want to think about as we're going? Okay? All right. Let's keep that in the back of our mind. Maybe tomorrow when we revisit this, will start by saying, you know what, Mrs. Kaleda, I think I would like maybe to present this way, have this option, have this option. I'd be okay with that. Okay? Then we can also talk about a rubric. How many points is it going to be to just figure out this, and that? Well, then bounce them off me. What are you thinking right now? What's your task at hand?
Okay.
Like how do they also could be the circumcision?
Well, these are going to be helpful for interpreting an EKG. Figuring out where the heart is might be better from your medical notes. Okay? The location of the heart comes from blending this Einthoven's triangle, which is 3 types of those leads, those electrical leads that are put on the body. Okay? Here's the first type. These are called the limb leads. Well, look, yes. So those are those leads on the outside. And then these are the other leads, the AVF, AVR, and AVL. They're different types of electrical leads that are placed on the body. When I put these together, the heart would be at the center, which is that point of concurrency. So if you can start to figure out what's happening between the triangle, the Einthoven's triangle, and these leads, you'd be able to see. Maybe look at another page. Look, here it is when they put it all together. Those are your leads 1, 2, and 3. Those are your AVR leads inside when it's all put together. What's kind of happening? That would be your heart at the very center where they're concurrent.
What do you mean what is happening? Like, what do you mean like finding out? It's like
So if the heart is at the center, right here. Well, no, it's not the center of gravity. It just happens to be right where these 3 hit. The point of concurrency, I should say, not the center. Okay? What are these AVR, AVF, and AVL leads doing to the triangle? Are they perpendicular bisectors? Are they medians? Okay? Are they angle bisectors? Are they altitudes? How do you know? Okay, so start to kind of figure out what kind of angles or degrees or what's happening there. Okay? Great. Let's take a quick time out. Okay? Here's a couple of extras that I want to talk about. Obviously, we are going to be spending tomorrow on this and maybe even Wednesday. I know that this is not going to be a quick one and done project. This is requiring some thought process. Okay? So we have like 2 more minutes left. I want to talk about 2 things. Alright. Alright. So, first thing is I have a couple of checks up here. I want to check in with you as we continue this. Okay? 1 is dealing with finding the location of the heart. That's this blue quick check. Okay? I also have this yellow quick check, which is interpreting the EKG. 2 separate tasks that you're already doing. This is me checking in with you to see how you're doing. I don't care which one is done first, okay? You can save them both for at the end, or once you've tackled one task, do one, then do the other once you've tackled the other, okay? At least by tomorrow, I would like one of these to be done, okay? And then hopefully both of them by Wednesday when this project is complete, okay? Perhaps take the last minute of class, talk to each other about splitting up some of this research. Don't just forget about this when you leave today, okay? Split it up. Divide and conquer, okay? And then lastly, we are going to start, ladies and gentlemen, lastly, we are going to start class off tomorrow with you giving me some ideas of what you want to do for a final presentation. Whether it's an oral presentation, some sort of model like Patrick is doing so lovely right now. Okay, I think they're on the right track for something. All right? Or if you want to do some sort of Google Docs presentation, that's your choice. But I need ideas. Because once we come up with ideas, we need to talk about point values for everything. Okay? Is that fair enough? All right, you have about 30 more seconds.
Yeah.
Divide and conquer.